BIM is an engineering process that optimizes the planning, design, and fabrication elements of a project. BIM stands for Building Information Modeling. BIM is based upon two concepts. First is the creation of an intelligent model. This model would have information parameters beyond 2D and 3D data. Parameters such as material properties, detailed mechanical connections, clash detection, cost and schedule analysis would all be included. This would increase the accuracy and precision of a project. Second is the coordination of the model live across all platforms. Engineering, contractors, fabricators, and the client would have access to the model. Any changes from a party would be seen live across all platforms. This will increase the efficiency of the project. BIM uses a combination of software and technology to create an intelligent model. Drone and 3D scanning would be used to capture data and generate point clouds. Using point clouds allows for the highest degree of accuracy possible and time saving. No extra travel time would be required to obtain data of a missing dimension or to check for spatial clearance. Detailed information beyond dimensions such as flange sizes and thickness of materials can be extracted from point clouds. We are able to gather site data and generate 3D model of existing terrain. 3D scanning increases our accuracy by a factor of 2 and precision by a factor of 2. This totals to an efficiency increase by a factor of 4. Parametric modeling programs, such as Revit and Advanced Steel, mean that materials properties and detail connections can be extracted directly from the model. Fabricators can directly input data from the model into their machine. This will expedite the fabricating process. Structural analysis programs, such as RISA 3D and Robot Structural Analysis, inspect the structures for weak points. Design corrections and optimizations are instantaneous. There is no need to redo complicated and lengthy calculations. Our engineering design process is not only holistic, but also adaptive to technical advancements. Cost and schedule are controlled using 4D and 5D BIM simulations. We are able to animate the constructability of major steps in project development. Clash detections and simulations allow the project to be checked spatially for any interference and bottleneck in the construction sequencing. Using recap and novice works, new equipment can be incorporated with existing equipment. Virtual walkthroughs are possible and are used to check for any potential hazard. There are different dimensions to BIM. 3D is the creation of a 3D model. A 3D model allows the flow of construction to be much more efficient, and troubleshooting is much more effective using the 3D model rather than 2D drawings. 4D is attaching the construction sequence to the model. 5D is attaching the cost on top of construction sequence to the model. 4D and 5D simulations allows the constructability of the project to be monitored and implementation of budget control in critical times. Bottlenecks in construction sequencing can be avoided ahead of time. 6D is integrating the operations and maintenance to the model over its expected lifespan. 6D integration allows for predictive control, where key parameters can be self-monitored and diagnosed. The intelligence of a model increases with the addition in dimensions. The more intelligent the model is, the higher the accuracy and precision of the project will be. BIM uses a process of coordination between all platforms. Engineering, contractors, fabricators, and clients are all part of the coordination. Engineering would take ownership of this process. Engineering is the glue that holds all external information together and responsible for checking and design implementation. This process is about distribution and control of design information. It would be a combination of primary and secondary data. The primary data is the 3D model with the layout of the project. This would be the common transfer point for everything. The ownership of this 3D model is with engineering. Secondary data are pieces of information that are incorporated into the main model. Information such as mechanical equipment, structural steel, and dust collection system. The ownership of this data is with contractors and fabricators. There are three major advantages to the application of this process. First, with full integration, the client can see the model live with the latest layout and equipment update. Second, is the design process would be more accurate and precise, because everyone can see the bigger picture. Interference and clearance issues would be spotted right away. Third is efficiency, because there would be no loss of design intelligence between each revision, and if all vendors provide 3D models, with correct spatial information, then design checking and implementation would be very systematic. To execute BIM, a BIM execution plan need to be implemented. This document would lay out the responsibility of each party, along with the steps and procedure of the project. It was found by using BIM, key project parameters can be influenced. Parameters such as design time, construction time, the numbers of change order and the number of RFI, can be reduced. BIM is now used globally across North America, Europe, and Asia, and is the future of engineering. BIM is the answer to delivering your next great project. For more information, visit us at www.ktceng.ca.